3.2 continue. This is video number 3 where we're going to talk about graphs of piecewise defined functions and greatest integer functions. Now remember, a piecewise defined graph is a function that has many different rules for your graph. Now for this we have, for the first one, f of x is equal to x squared if you have x values less than or equal to 1. So remember, this is just a quadratic graph. What I like to do is I start at my restriction. So I'm going to start at an x value of 1 and we are less than or equal to 1, so it's going to be a closed circle. When I put 1 into x squared, well, 1 squared, so I'm just going to really make a table. So when I plug 1 in, 1 squared is equal to 1. So at 1, 1, I have a closed circle, and then I'm going to do values less than that. So at 0, I would have 0 squared, which is 0. Negative 1 squared would be 1. Negative 2 squared would be 4. Negative 3 squared, of course, would then be 9. And so on. And my graph is only this part from that x value is less than or equal to negative 1. So then for the next part, we're looking at x values in between 1 and 4 for the function f of x equals x plus 2. So for this one, I'm going to make a table of values. And I'm going to start with 1. Even though we're not equal to 1, I still need to figure out where my open circle on my graph is going to be. So when I plug 1 into this equation, 1 plus 2 is 3, but remember that's going to be an open circle because, again, we're not equal to 1, we're just x is greater than 1. Then for the next part, I want a value in between 1 and 4. Doesn't matter what value I pick, no. So let's just go ahead and pick 2. 2 plus 2 is 4. And then I'm going to go to my last part, which is 4, and we're equal to 4, so that's going to be a closed circle or closed dot on your graph. And when I plug 4 in, I get 6. So on my graph, that means I have a line from 1, 3, which again is an open circle, and then I have the point 2, 4, and if I plugged in 3, I would get 3, 5, and then I have 4, 6, and it's a closed circle there, so I just need to connect those values. You get a line there, so it should be a straight line, of course. And that's what my graph would look like. Now for this graph, if we had to find the domain and range, the domain would be from negative infinity, and it would go all the way to an x value of 4, including 4, because we go from negative infinity here, we have this x value defined there, which is okay, so we go all the way to 4. And then my range values would be going from here to infinity, so the range is going to be from 0, bracket 0, to infinity. Now, remember we said in the last section, 3.1, that we can graph this in our calculator if we want to. So if I graph this in my calculator, and I'm going to clear that out from the last video. So go to your y equals, and in your y equals, remember we said you can plug it in, so this would be x squared, oops, forgot the x, so x squared, and then we use the division symbol to do this restriction part, so parenthesis x, if you go to second math, that gives you these symbols, and x is less than or equal to, so number 6, and then it's less than or equal to 1. And then remember we said we can't plug in some, x values in between two numbers, we have to do it separately. So then for the next part I have x plus 2, use the division symbol, parenthesis, parenthesis, 1 second math is less than, so number 5, x, and then close parentheses, and like I said, I don't remember, I said you have to do it separately, otherwise your calculator won't be able to do it. And then x second math is less than or equal to, so number 6, 4, close parentheses twice. And if you hit graph, or I'm going to hit zoom 6, Notice this is what your graph looks like, and if you look here, that is exactly what our graph looks like when we graphed it by hand. If you look at this graph, it's hard to tell, that we have an closed circle here and an open circle here, but if you look at your table, and I'm going to go back to my window, second window, I'm going to put this at 0. I'm going to start with values of 1. And I'm going to go to my table again. Oops, second graph. Notice that this was the first equation we put in, so notice we only have values that are less than 1. Everything above 1 would say error, so notice that we only have the values less than that. And here we only have values starting at 2, 4 that go to 4, 6. But what happened to the point that was in between, because don't we have an open circle and these values here, you just can't see it because we're going by whole numbers right now. So if I go to second, or integers I should say, so second window, and I'm going to do, let's do 1.1. Notice if I put 1.1 in and I go to my graph, we do have values. Oops, sorry, not 1.1. I should have done 0.1. So I do 0.1 and go to my graph. Notice I have values here. It's just that if you didn't change that on your window, you wouldn't have seen that you had values in between as you start right here. So at 1.1, notice we have 3.1. At 1.2, we have 3.2, and so on and so forth. Whereas before, remember, it just said that we were starting at 2, 4, which would have been incorrect. So that's why when I'm graphing these, I like to do it by hand, and I always start with my restrictions in order to help me graph them. So then for the next part, graph, we're going to do the same thing. Notice this is just absolute value. So for the absolute value, I just wanted to show you that it is a piecewise defined function. This should have said values of x less than 0. And when you graph it, I'm not going to take the time to graph them each separately, but one side of your graph would go this way. The other side of your graph would go this way. The domain for this is all real numbers. And the range is also all, is from 0 to infinity. So like I said, we're not going to worry about that one because we've graphed absolute value before. Let's do some harder problems. For the greatest integer function, we've talked about this, and you need to know what the graph looks like. So I'm just going to graph this again just to show you. You have a closed circle here. This would be an open circle, closed circle, open circle, closed circle, open circle, closed circle, open circle, and it keeps on going. And you do need to know what this graph looks like because we're going to be doing transformations in the next section. And so remember that it kind of looks like a step function, and because for this, the greatest integer function, remember you're always rounding down, so anything in between 0 and 1, but not including 1, would round down to 0. Anything in between 1 and 2, not including 2, would round down to a y value of, or sorry, in between 1, so like 1.1 would round down to 1, etc. So the domain for this is all real numbers, because we can plug anything in for x, and our range is going to be integer answers. And we've talked about that before. So let's go ahead and do this last graph, which is the really complicated one. For this last graph, notice that our first restriction is for -2u minus 2 if u is less than -3. So we're going to graph this one first. And I'm going to make a table. If I start with my restriction, which is -3, it's going to be an open circle at that x value because remember it's u less than -3. But if I plug -3 into this equation, -3 times -2 would give me +6, minus 2 would give me 4. So on my graph, I have the point -3, 4, and an open circle. And then if I do another point, so let's do negative 4. Negative 4 times negative 2 is positive 8, minus 2 is 6. So I have negative 4, 6. And I could keep on going if I wanted to. So the next point would be here, etc. So then I use my ruler, connect my line. And then let's go ahead and do the next restriction. So for this next restriction, we have u minus the greatest integer of u. So this one's going to be a little bit more difficult. So if I do negative 3 and plug it into that function, I would get 3 minus, and the greatest integer would be negative 3 inside. So 3 negative is already integer, so then we really just have 3 minus negative 3. So 3 minus negative 3, or sorry, this should be negative 3 minus negative 3 would be negative 3 plus 3, which is 0. So I have negative 3, 0, and it is a closed circle because we can be equal to. So let's do our other part, which is 1. If I plug 1 in, I get 1 minus 1, which is 0. But that doesn't really help me out very much with this graph. I still need to figure out what's happening in between. And since I'm working with the greatest integer function, it would be helpful to, let's start with values in between negative 2 and negative 3. So let's do negative 3, let's do negative 2.9. So if I plug negative 2.9 in for u, I would get negative 2.9 minus the greatest integer function of negative 2.9. So when I do that, that's really equal to negative 2.9, and this would be minus minus, which would be plus. This rounds down to, that's going to round down to negative 3, so that would be plus 3. So negative 2.9 plus 3 ends up being 0.1. So if I do another point, so let's do negative 2.8. So it would be negative 2.8 minus negative, this rounds down to negative 3. So negative 2.8 plus 3 ends up giving me 0.2. Then if I do another value, I have negative 2.7 minus negative 2.7. So when we do our greatest integer function of negative 2.7, it rounds down to negative 3, so that would be minus minus again. So that ends up being plus, so negative 2.7 plus 3 ends up giving me 0.3. So notice that it appears my graph is doing something like this. And if I do the next one, each of these values in between would go something like that. And then we only have values in between. Then, and again, you can keep plugging in points to see that. So then for the last part, I have u is greater than 1. So for my table, if I plug in 1, we're open circle at 1, so 2 times 1 squared would be 2. So at 1, 2, I have an open circle. And then if I plug in 2, 2 squared is 4 times 2 is 8. And so it's just a half of a parabola, so it's kind of hard to draw. So it looks something like that. Now, I can also check this on my graphing calculator. So when I go to my graphing calculator, I'm going to go to the y equals and clear these out. So I'm going to have to plug all this in. For y1, I have negative 2x minus 2, division symbol, parentheses, x second math, number 5, and negative 3, close parentheses. And then for the second one, I have x minus, and to get the greatest integer function, remember you go to math, and it's over to number, and then number 5, so right over to number, and then go to number 5, x. close parentheses. And then we need the restrictions. Remember, since it's in between two numbers, you have to do it separately. So division symbol, parentheses, parentheses, -3 second math is less than or equal to, which is 6. X, close parentheses, and then parenthesis, whoops, I did too many there. So parenthesis, X, second math, number 6 again, 1, close parentheses twice, and then for y and y3, I'm putting 2x squared, division symbol, parentheses, for x values that are second math, greater than, so number 3, 1. And if I hit graph, notice this is what my graph looks like. So my graph looks the same, and I'm going to zoom in on the greatest integer part, just so you guys can see. So I'm going to zoom in here. So if I zoom in, I can see better what's happening right there. If I hit trace, notice it tells me what function I'm on. So I'm on y1 right now. So if you hit the down arrow, it takes you to y2, which is this middle one. If I hit the down arrow again, it would take me to values on the y3 that I have plugged in. So I'm going to go back to y2. Notice that, see, these are just values that if you plug it into that function, that what you would get out. And notice that right here, it makes the jump. And so that's another way you can tell what's happening on your graph. You can also go to your table, and for my table, I'm going to put in 1, and I'm going to change my table back to just 1. So second graph. And notice that for this, if I go to -1, the first one shows up. I can also scroll over with my right arrow if I wanted to see what's happening on y3. So notice that you can do that, which is pretty cool. And then here it gives you 0 for all your answers because remember I still have stuff in between -3 and -2, which is all this that we did. It just doesn't show up because we're only looking at our integers right now. And then for the last part, I have errors for these both because there's nothing there. It's not on my graph, but I do have numbers for this part, which is in blue. So if I go back to my graph and I'm going to hit zoom 6 for a standard window. So zoom 6. And just to show you again, if I hit trace, I can go to the different graphs. I'm on y1 right now, and notice that at x equals 0, I have nothing up. But if I go to less than that, because remember our first graph starts at x values less than negative, what was it, 4? Notice that I can get y values now, and then if I do, I'm going to go to y, whoops, let's go to y2. y2 and hit trace. Oops, now I'm on y3, but I can do y2. You can see the values come up. So that's another way you can look at your graph. So there's lots of little different things you can do. This one was just really difficult because of that greatest integer part, but just remember the greatest integer function just means that you're rounding down to the nearest integer. So when you have values in between, like the -2.9, it round down to -3, -2.8 rounded down to -3, -2.7 rounded down to -3, and you just were subtracting or adding them together. So bring this with you to class, and we are going to do more practice of this.